Welcome to another deep dive. This time into the world of AI. AI that can interact with the world in real time. Processing, streaming, video and audio just like we would as humans.
Yeah. It's a really fascinating area right now, moving way beyond, static image recognition and getting into this continuous understanding. Imagine a future where AI can actually see and hear the world around it.
Yeah, constantly learning, changing. Pretty incredible. But there's a problem, right? Most AI models right now, they struggle with real-time responses. They struggle to remember stuff from long interactions. It's like trying to talk to somebody who forgets what you just said like 5 minutes ago.
Exactly, yeah. And I think that comes from the traditional sequence-to-sequence architecture that most models are based on. This is that kind of step-by-step processing, they're following a recipe, they can't really think while they're watching the video.
Right. And to add on top of that, just storing all that video and audio data for long periods, that gets really inefficient.
Yeah, for sure. But the research paper that we're looking at today introduces this groundbreaking new system called InternLM-XComposer2.5-OmniLive.
Catchy.
Or IXC 2.5 for short.
There we go.
It's a lot easier.
Yeah.
It takes inspiration from something that's pretty familiar to us, the human brain.
Okay, now we're talking. So how does this brain-inspired AI work?
So IXC 2.5 is built with three main modules. There's the streaming perception module, there's also the multimodal long memory module, and then finally there's the reasoning module. Each of these plays a specific role, kind of like different parts of our brains.
So like a team of experts all working together. So tell me a little bit about how each of these modules work.
Sure. So the streaming perception module, think of that like the eyes and ears of the system. It's constantly taking in information from those video and audio streams and processing it all in real time. So unlike traditional models, it doesn't need to wait for the entire video to be loaded before it starts to understand what's going on.
Okay, so it's constantly thinking and processing. That's a big step forward. But what happens to all this information pouring in? Does it just disappear?
No, it definitely doesn't disappear. And that's where the multi-modal long memory module comes into play. It's not just a simple storage unit. It's more like this organized filing cabinet. It takes all those short-term perceptions, compresses them, and integrates them into this long-term memory bank. And that makes retrieving information later on much faster and more accurate.
Oh, so this memory module is key for handling these long conversations and interactions that we've been talking about. But how does the AI actually use this information to do something like answer a question or complete a task?
So that's where the reasoning module comes in. That's kind of like the brain of the operation. So it takes in a question or a request, gathers the necessary information from the perception and memory modules, and then it puts it all together to generate a response.
So it's kind of like the conductor of an orchestra, right? It's coordinating all these different parts and making sure they're working together.
Yeah.
Can you give me an example of how this would all come together? Like, say if I were to ask the AI about something that it was seeing in a video.
Okay. So let's say you ask what happened after the woman left the room. So the reasoning module would first have to figure out which part of the video is relevant. Then it would go to the memory module and say, hey, I need information about the woman leaving the room. So then the memory module gives the reasoning module this compressed essential information from that part of the video.
So the reasoning module isn't like searching through hours of footage. It's got a summary and it's very targeted.
Exactly. And that's what makes it so powerful and efficient. It can process, tons of information quickly, kind of like our brains do.
Okay. My mind is blown. And we've just scratched the surface. Let's dig into each module a little deeper. Let's start with perception. What's so special about the way IXC 2.5 perceives the world?
So the perception module actually processes audio and video separately, and that actually improves both speed and accuracy. It's like having, different teams specializing in each type of data.
Makes sense. Divide and conquer. And from the paper, they use specific models, right? Like Whisper for the audio and CLIP for the video. These are some pretty big names in the AI world.
Right. And by separating them, the system can leverage the strengths of each model.
That's pretty clever. Okay, let's move on to the memory module. This is where its ability to handle those long-term interactions really shines. Tell me about those three training tasks that make it so efficient.
So think of these tasks kind of like a training regime for the memory module. So first, you have video clip compression. So the module learns to condense the essential information from a video clip into a more manageable form, kind of like summarizing, a chapter of a book into a few key sentences.
So getting the gist without getting bogged down in the details.
Exactly. Then you have memory integration, which combines those compressed clips into a larger structure for the long-term memory. That's kind of like organizing all the chapter summaries you have into an understanding of the whole book.
And this is how it remembers things that happened hours, days, even weeks ago.
It really is. And finally, you have video clip retrieval. That's like a super efficient search engine within the memory. So when you ask a question, the module can quickly locate the relevant clips and information.
And that's where those semantics implicit question and reference implicit question examples come in. Like it can understand what you mean, even if you don't say it directly.
Yes. So for instance, if you ask, how is the weather today? The AI might not have a direct record of someone saying the weather was sunny, but it can connect your question to the visuals, like people wearing sunglasses or if the sun is shining.
Or if you're looking at the screen and you point at something and say, what is that? It can understand that you're referring to that thing on the screen, even though you haven't actually said what it is.
Yeah, exactly. That's a good example. So those examples really highlight its ability to understand context and implied meaning. And that's so crucial for natural human-like interaction.
So this memory module is not just passively storing things, it's actively analyzing and connecting information, really, just like our brains do.
Right.
That brings us to the last piece, the reasoning module. What makes this module stand out?
So what's really interesting about the reasoning module is that it doesn't just answer every input that it gets. So it first has to figure out if the input is actually an instruction that requires a response.
So it's got a built-in filter. It doesn't waste time on irrelevant stuff, just like how we try to focus on the important things and block out distractions.
Yeah, that's a good way to think about it. And that process is called instruction prediction, and that helps the AI decide which inputs are actually important and which ones can be ignored.
Okay, we've covered a lot of ground here. I mean, we've talked about the core challenges of real-time AI and then how these three modules of IXC 2.5-OL actually address those challenges. But how do we know if this actually works? How do the researchers measure its performance?
Yeah, that's where things get really fun. The researchers put IXC 2.5-OL through a whole bunch of tests. They use these different audio and video benchmarks to compare it against other leading AI models. And the results, well, they're pretty impressive.
Okay, now I'm really interested. Let's dive into those benchmarks and see what this brain-inspired AI can do.
Okay, let's start with audio. So they tested IXC 2.5-OL on two well-known datasets, one it's speech for Chinese and Libra speech for English. So these datasets have, various types of speech, everything from clear studio recordings to, those more challenging real-world conversations.
So they're not just testing it on, like, perfectly enunciated words. They're actually throwing in the messy, real-world stuff.
Right, exactly. And what's impressive is that IXC 2.5-OL actually achieves lower word error rates than other models like VITA and Mini-Omni. So it's more accurate at recognizing and transcribing speech, even with a relatively small language model. It only has 1.5 billion parameters.
Wow, it's a lean, mean transcribing machine. So it's really efficient. They're getting good performance without needing a massive, computationally expensive model.
Yeah.
Okay, what about the video benchmarks? What were the results there?
Those are where things really get exciting. So they tested IXC 2.5-OL on a bunch of benchmarks designed to evaluate different aspects of video understanding.
Like, for example?
Well, there's MLVU, which stands for Multimodal Long Video Understanding. So that one is all about making sense of, as you might have guessed, long videos, which is not easy.
Right, so it's not just a 5-second clip. These are long videos.
Right, so MLVU includes videos that range from a few minutes to even several hours long. And it tests the AI on various tasks, like recognizing objects and actions, understanding the plot of a movie, and even reasoning about the relationships between different characters.
So they're basically giving the AI a movie marathon and then quizzing it afterward.
Yeah, that's a good way to put it.
And how did it do?
So IXC 2.5-OL actually performed exceptionally well. It achieved state-of-the-art results with a score of 66.2% on this thing called the MFVG score. And that basically measures its performance across all those different tasks.
So like a well-rounded movie understanding AI.
Yeah.
But is this score good? Like, is it better than other systems?
It's really good. It actually outperformed even those massive closed source APIs from big companies, the ones that have access to mountains of data.
Right.
So that's incredible, especially for an open source AI.
So it's doing more with less. That's awesome. Okay, anything else stand out to you about its performance on this MLVU benchmark?
Yeah, it achieved this with only 7 billion parameters.
Mm-hmm.
So that shows that you don't necessarily need a gigantic model to get really good performance.
I feel like a broken record here, but that's pretty incredible. So open source, efficient, and it performs extremely well. What's the catch? Why isn't everyone using this?
Well, I think the main reason is that this research is still relatively new, but the fact that it's open source means that anybody can access and build upon this work. And that's really exciting because it allows for much greater transparency and collaboration within the research community.
Okay, so everyone can see how it works, how it's trained, and can contribute to its development. That's huge, right? Especially in a field like AI, where things are moving so fast.
Right, and that's what makes the success of IXC 2.5OL so exciting. It demonstrates that cutting-edge AI development isn't limited to these big tech companies with huge resources.
This is really exciting stuff. We've covered so much ground already, from, the inner workings of this brain-inspired AI to its amazing performance on these standardized tests.
Right.
But there's so much more to unpack. We're back, and we're diving deep into IXC 2.5OL. This AI system is learning from the human brain to really understand video in real time. And before the break, we were just starting to talk about all those interesting video benchmarks.
Right. So we were looking at how IXC 2.5OL stacks up against the competition. We talked about MLVU, where it got some amazing results. But there's another benchmark that I think you'll find really fascinating, Video MME. So this one focuses on how well the AI can take its understanding and apply it to all sorts of different video content, like news, documentaries, even social media.
So it's like, okay, you've watched a bunch of nature documentaries. Now let's see how you do with a cooking show. That's a really important skill for any AI that's going to be out in the real world, right?
Yeah.
We're constantly bombarded with all these different types of visual information.
Yeah, exactly. And on Video MME, IXC 2.5OL scored a pretty solid 60.6% overall. So that really shows its ability to adapt to different video styles and formats. It's not just good at one thing, it can handle a lot of different stuff.
That's impressive. But how about the real-time processing? I mean, we talked about how that streaming perception module is designed to handle information as it comes in, but how do we know it can actually keep up with a live video feed?
Right. Well, that's where Streaming Bench comes in. This benchmark is all about how well the AI can understand and respond to a video as it's playing. So the system has to be super fast and accurate, which, as you can imagine, is a pretty big challenge.
It's like asking the AI to watch a live sports game and do the commentary. Right. Like no rewinding, no pausing. It has to keep up with the action as it's happening.
Yeah, exactly. And on Streaming Bench, IXC 2.5OL got a really impressive score, 73.79% overall. And to put that into context, it even beat out some bigger, more complicated models.
So it's fast, accurate, and efficient. This is sounding better and better all the time. But are there any areas where it struggled? Were there any benchmarks where it didn't perform as well as expected?
Well, no system is perfect.
No.
There were definitely some benchmarks where IXC 2.5OL didn't get the very top scores, but even in those cases, it was still very competitive, especially when you think about its relatively small size and the fact that it's open source.
That's a really good point. It seems like this IXC 2.5OL is really raising the bar for what's possible with open source AI. But I'm curious to go beyond the benchmarks. Where do you see this type of real-time AI having the biggest impact out there in the real world?
The possibilities are really huge. Just imagine AI assistants that can not only respond to your voice commands, but can also understand the context of what you're seeing.
Okay, yeah. So instead of just saying, like, play some music, you could point at your guitar and say, I want to learn how to play this. And then the AI could instantly pull up, like, tutorials specifically for the guitar.
Exactly. Or think about accessibility. AI that can process visual information in real time could give audio descriptions for people who are visually impaired. Make the world around them much more accessible.
Wow, that's incredibly powerful. It's like giving someone a whole new way to experience the world. What other areas are you thinking about?
Well, healthcare is another big one. Just imagine AI that can analyze a live feed from, a medical procedure. It could help surgeons be even more precise, maybe leading to even better outcomes for patients.
It's like having an extra set of expert eyes in the operating room, constantly monitoring everything. That could really change how surgeries are done.
Absolutely. And then, of course, there's education. IXC 2.5OL's ability to understand complex events as they happen could really revolutionize interactive learning.
Yeah, I mean, instead of students passively watching a video about the solar system, they could actually interact with it, like asking questions and moving things around. That would make learning so much more engaging, right?
Absolutely. The potential here is just massive. And because IXC 2.5OL is open source, it means that developers and researchers from all over the world can access and use this technology. So that can really speed up the development and push the boundaries of what AI can do.
This is really exciting stuff. We've talked about the inner workings of IXC 2.5OL, and we've seen how well it performs. We've even touched on some real-world applications. But before we get too carried away, I think it's important to take a step back. Are there any potential downsides or challenges that we should be thinking about with this technology?
Yeah, that's a really important point. As with any powerful new tech, there are always potential risks that we need to be aware of. One big concern is bias. AI systems are trained on data, and if that data is biased, then the AI can actually make those biases even worse. So that's something that researchers are working really hard to address, but it's an ongoing challenge.
Yeah, that's crucial, right? We need to make sure that these systems are fair and that they don't discriminate against certain groups of people.
Absolutely. And another big consideration is privacy. Real-time AI, by its very nature, processes tons of information, and that could include some really sensitive data. So we need strong safeguards in place to make sure all of that data is handled responsibly and ethically.
That makes sense. As AI becomes a bigger part of our lives, we need to keep control over our own information and how it's used.
Exactly. And these are just a couple of the challenges that we need to be talking about. As this technology keeps advancing, it's really important to have these open and honest conversations about the risks and benefits, and of course, to work together to find solutions that ensure a positive future for AI.
I completely agree. This has been a really insightful discussion, and I bet our listeners are just as fascinated by all of this as we are. But we're running out of time for today's deep dive.
Yeah, unfortunately, all good things must come to an end, right? But before we go, I want to leave our listeners with one last thought. The development of IXC 2.5OL is a huge step forward for real-time AI. It really shows the power of open source, and it gives us a glimpse into this future where AI systems can seamlessly understand and interact with the world around us. But as with any powerful tool, it's up to us to make sure it's used for good.
Well said. And to our listeners, we really encourage you to check out the research paper for yourselves. Dive in and explore this incredible world of IXC 2.5OL and the future of AI. This is just the beginning, and who knows what amazing things are coming next. Thanks for joining us on this deep dive. We're back, and we've been exploring this amazing AI system, IXC 2.5OL. It's pushing the limits of how AI understands video and does it in real time. And one thing that really stood out to me was its ability to handle these really long video sequences without sacrificing accuracy. I mean, that's something that a lot of traditional AI models really struggle with, right?
Yeah, absolutely. As those videos get longer, the processing power needed, it just skyrockets. It gets really hard to maintain that level of accuracy.
So it's not just about understanding a short clip. We're talking about AI that can watch hours of video and still make sense of what's happened.
Exactly. And it can do that because of how it compresses and stores information in its memory. It can quickly pull up those important details when it needs them. It's almost like having a mental map of the whole video.
Okay, so it can remember things and find what it needs quickly. That opens up a lot of possibilities, right? Like, could AI start understanding complex narratives, tracking events over time, maybe even predicting what's going to happen next?
Yeah, definitely. And that's where it gets really interesting. Think about AI that can analyze security footage to find suspicious activity, or AI that can predict traffic patterns to make transportation more efficient, or even AI that can help us understand climate change by looking at years and years of satellite images.
Those are some really compelling examples. I mean, it sounds like this tech could have a huge impact across so many different fields, but I'm also wondering about its limits. Is there anything that IXC 2.5OL still struggles with?
Well, like any AI, IXC 2.5OL still has some challenges with ambiguity and uncertainty. The real world is unpredictable, There are always unexpected things happening, and AI has to be able to adapt to that.
So it can handle a lot of different scenarios, but when things get really weird or unexpected, it might have trouble.
Right. And that's something that AI researchers are working on right now, trying to build systems that can deal with that uncertainty and make good decisions even when things are unclear.
It sounds like there's still a lot of work to be done. But IXC 2.5OL feels like a big step in the right direction.
Yeah, I think so. And the fact that it's open source really opens up a lot of possibilities for future research.
Absolutely. Well, this has been a truly fascinating dive into the world of AI. I've learned a lot about IXC 2.5OL and the amazing potential of this technology.
It's been great chatting with you about it. Hopefully, our listeners are just as excited about the future of AI as we are.
To our listeners, I really encourage you to check out the research for yourselves. It's a fascinating journey. This is really just the start. Who knows what's coming next? Thanks for joining us, and we'll catch you next time on The Deep Dive.